guys, welcome back to the last video with with the last part of geometric series. I didn't want to put this one into the other one because I thought it was too long, but I want to touch just 3 pages to kind of introduce the an infinite number of terms. Many of this geometric series, when we talk about infinite numbers, it's mainly focused in calculus, but like I said, like it's written there, we will only study special cases of geometry series where the radius is less than one. We use the symbol for infinity to indicate that the number of terms is unbounded. The symbol infinity does not represent a number. In infinity series, the indicate sums of all terms of a sequence is called an infinite series. For a sequence, the corresponding series can be written as follows. Infinitive, the summation of the first term through infinity in terms of a sub k. In this case, we will only look at this. I will try to explain what's happening here. So what we're doing here is just adding to the infinity number. So we're adding the first term, the second term, the third term, and I put n because it keeps going and on and on. N represents any number. For geometric sequences, in this case, where the radius is less than 1, it can be shown in higher level of mathematics that the radius to the power n approaches 0 as it approaches infinity. This does not mean that r to the power of n is ever equals to 0, only that it gets closer to 0 as it becomes larger and larger in symbols with right. I don't know if you ever had or somebody explain what what is the significance of limits of an infinity sequence. Let's think about it like how to get to 1. Obviously the closer number to 1 would be 0.99, right? But if we can always add 0.999999, so the numbers that follows that 9 are infinitive because it, because this is very, I don't know if you ever thought about or somebody or of a teacher thought about this, but that's basically is an infinity. It's saying we're getting closer to this number, but because the numbers are so small that we say, okay, infinity, it's kind of the same as the example that I just said. The 0.999999 to the infinity, obviously it's not to the infinity because, well, the number keeps going until it reaches 99999 and it keeps going. So that's what we call infinity. And in this case, as I use an example like 0.99999, it gets closer to 1. This So the same thing it's saying here. This did not mean that r to the power n is ever equals to 0. So you will never reach 1 because there will always be a point 9 behind. That only it gets closer to 0, but in this case that I say is 1. As an n becomes larger, the number, right? It gets larger at 0.999 and larger. In symbols, we write that that number it's an infinitive number. Now there are infinitive positives, infinitive negatives, in which you put the symbol right up top of the infinity. That's in when we define what's a limit. I I saw that in logarithms where or in when you divide two fractions that contains x, that contains a factorial, and that number gets to the infinity, you will write plus or minus depending if the number is positive or if the number is negative. I think it's something like that. I will bring up another. Well, it depends of you if y'all wanna look a review of pre-calculus, which we talk a lot in what's limits in pre-calculus before jumping to calculus. But it's pretty much that. Thus, we had the following result that the radius. Remember what is the radius, right? It's the number of the sequence that by dividing those two number of a series we get the radius. But if that number it's less than 1, we will have to develop this because if we look at the formula that we developed last video, if this number is less than 1, then it gets to 0. So 1 minus 0 is like saying we just only have a to the 1. We only take the first limit. We only take the first number of the sequences. So to write it in this way, in the sum notation, would be the summation of the first term through the infinity in terms of a sub k. And as you see here is the first term as it's been added to the second term times the radius. And as we explained before, the radius it keeps adding the powers because the less number gets another radius, so we add it because of the rules exponents. So at the end of the day, like we say, the number above gets 0 because the radius is less than 1. Now, whenever we have a fraction that's less than 1, it's a really small number. So they decided to add the 0 and to cancel everything and just to have the first term. So let's look at one example. This is in a special case. Let's look at this example. So we have to the infinity We have that k, the first term of k is being added to the infinity in terms of 2 divided by 3 to the power of k minus 1. So we substitute the first one, 1 minus 1 is 0. Now when you multiply an exponent by a 0, it's 1. Because let's say you have something and you want to multiply and you want to power it to something that it's nothing. Obviously you may think, okay, but that should be 0 because if we multiply a number by 0, it's gonna get 0. But in the powers, there's this concept of nothing, right? Because we're saying we're multiplying by 0, but 0 is nothing. But there is a rule that even nothing has to have a value. So the, there's an interesting proof that says that if we divide or if we power it to something to 0, we will get 1. That 1 represents the concept of nothing. Really? Yeah. Okay, but let's go to the next one. So we have 1 plus to the same number because it's 1 to the 2. Remember, if you keep adding 2, if you power into, you power to the lower number and to the upper number. So 4, 9, etc., 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 etc. So before we have all of these numbers, now we can say, yes, we have a sequence, right? 1, 2, 3, 4, 9, 8, 27. So we took the first term and we took the rate and we take the radius. Now, how do we know we have the radius? Remember that we have to memorize how it's the formula. The formula says that we only need the first term on top and we have to divide this 1 minus the radius. How do we get the radius? We the radius we get the radius by dividing two numbers. So if we divide the second term and the third term, we were supposed to have the radius. If we divide the first term and the second term, remember that the second term has to be on top and the following sequence or the sequence that is in the back has to go lower. In this case, the 2 and 3 has to be up and the 1 has to be on the bottom. So we will have the same 2 over 3. You can do this if you want, but the radius is this as we explained before in the geometric series. So we will do that. We will take the first term, that is 1, divided by 1 minus the radius. As we see here, we have 1 divided by 1 over 3. Now, to get 1 over 3, remember that we have to have a same denominator below. So we have to multiply by 3 on the bottom. And if we multiply on the bottom, we have to do it on top. So we have 3 and 3. 3 divided by 3, it's equals to 1. But we have to have the same denominator. So 3 minus 2, the 3, it's in front, it's bigger, so the result will be positive. If you have a negative number and you're subtracting another number that it's, let's say, it's less, you will that number will be positive because of the rules of substitution. You can substitute whenever you have two numbers that are negative. Remember, the number you will the number will be added and will be positive. Okay, let's go to the next one. So the whole summation of this is equals to 3 right here. 3. Let's go. Let's go to the next one. So the other one, it says that we have 0.003. Now all of those numbers are equal to 0.3. This formula shows that the decimal number can be interpreted as a geometric series. So if you have 0.3 or 0.0003, as you see here, we're trying to get the radius. In this case, we don't have a in terms of what are the summation, but we want to know if 0.3, if we keep adding 0.3 to the infinity, what will be the number? So if we divide 0.3 by 0.03, we see if we multiply 1 divided by 10, we will get the same result. If we do 0.03 divided by 0.003, we will, or flip it, we will have 1 over 10. So now we know that we have the radius, a common r. So we take the first term, 0.3. We can write it in 3 divided by 10. We take the radius, which we know that 1 divided by 10 is 0.1. Why the radius is 1? Is easy because if we take two sequence number and we divide it into them, we get the same answer. As we explained before, that's how you get the radius. So to add, we took the first term divided by 1 minus the radius. As we explained before, we have to hide the same denominator on the bottom, and we have to do the downside of the division first, because we need to have just one division without subtracting or anything. We just had to have one number below on the denominator of the division. So we get 10, 10, 9, 10. Now we flip it. We took the first one, 3 divided by 10 times 10 divided by 9. We just flip that. The lower division. It's like saying this number is bigger, but we're gonna take it to the lower and we wanna multiply to and this will give us an equal or a fair equation. But we're not gonna multiply. We're just gonna simplify. So we have 10, 10, 1, 1. We divide by 3, 1, and 3. So we have 1 on top, 3 on the bottom. The whole summation of this is 1 divided by 3. It's pretty much about it because when we talk about limits, remember that we're talking about just the summation of repetition, or in this case, we will be only needing the first term and the radius and memorize the formulas and just apply it, and you can do any summation of an infinite number. Then, doing adding to the fifth number, you now with all of this information, you can actually solve it pretty easy, remembering the formulas. So if you learn something new, I suggest you to subscribe. I will be starting uploading physics 101 of college. I will do my best to upload some pre-calculus topics, and that will do until Christmas, I guess so. But thank you so much for watching. I don't wanna take more of the time. I hope this was helpful. I will probably expand this in the future when we get to calculus, probably differential of equations. That is calculus 3. You will see something with uh, in calculus 2, but this will help to algebra. This is a this is a topic algebra really because we're not touching anything with that anything that gets into calculus. This is kind of like knowing before going into calculus. So if you only have, if you're in the middle school or high school, I think you can really understand this because I haven't talked any hardest topics. But that's it. I will be uploading the next video, which will be the binomial factorial and the binomial theorem, which I think it's phenomenal if you are in high school and you're taking algebra 1 or algebra 2. This binomial theorem will help you a lot, will save you a lot of your time. So, but this is also part of sigma notations because we'll be adding and we will be using the factorials. So keep it tuned. I have already the Google slide, and we'll see you next time.